We are going to start a topic that is a telescope. Basically, it is an astronomical telescope. It is an astronomical telescope. Okay. Now, astronomical telescope is basically it is an optical instrument. Okay. And it is used to magnify a distant objects, means the objects that are very far, or the object is on infinity. Okay, now the astronomical telescope is basically used in astronomical bodies to to see astronomical bodies, for example sun, moon, star, etc. These are the astronomical bodies that are in space. Okay, if we talk about its working principle, the working principle means the visual angle will increase. Okay, and this the astronomical telescope, the visual angle will increase. If we talk about its construction, there will be two convex lens. Okay, one will be optical lens, or we can say object lens, and second will be eye lens. Okay, there will be two lens, convex lens, but one will be optical lens and second will be eye lens. The optical or the object lens will be big and the eye lens will be small. Here, if we talk about its focal length, there will be the larger focal length. Okay, and here will be the shorter focal length. Then the image that will form here, it will be real, inverted and diminished, very small, because we are having a because same symmetry, so it will be smaller. Inverted because they are these are the astronomical bodies. Okay, so these are at infinity, so there will be real, inverted and diminished. Now here it will be virtual, inverted and magnified. Okay, magnified because we are seeing it from the islands, because we are seeing it from the islands, so it will form a big image, as the work of it is to magnify a distant object. Now if we talk about its whole construction, for example, let me make this is an eye lens. Okay, and this is an object lens, as object lens is big and eye lens is short. Okay, that is an optical center, the focal length of both. Okay, this. Now first of all, the ray that will move from the optical center, for example the object is placed at infinity, that is an object placed at infinity. Okay, first of all the ray will move from the optical center, and second ray, as we know, will move from the focal length. In some point it will go and merge, we don't know, because the object is on infinity. Okay, then the point where they are merged, the ray will move to the eye lens. It will move from its optical center, and second ray will move from its focal point. Now the point where these both are merged, okay, means the ray that comes from that side, it will move to the optical center, and one ray move from the focal length. Okay, Now the focal length of the point means the focal length of the eye lens and the focal length of the optical lens or the object lens is similar, so that is known as the normal adjustment, means where both lens line will meet at one focal length, that is known as the normal adjustment. Okay, now this is the magnification. This now we are calling it a point C. For example, this is A point and this is B point. Okay, now the angle that is formed here is beta, and here the angle that is formed is alpha. Okay, now we are having, we know the magnification is equal to beta upon alpha, that is a first equation. Okay, now in angle triangle ACM, that is making a triangle like this, ACM. Okay, in ACM we have to find alpha. Okay, now we know okay, let me tell you one thing, that is the focal length of, that is the C point, that is the focal length till here, it is the focal length of eye, and till here it is the focal length of object. Now we know that this is the distance, so distance is means the length we can say it is FE plus FO, total length will be FE plus FO. Okay, now here we know FO, and that is we know the perpendicular and base. Okay, we know perpendicular and base, so we have to find alpha. We know perpendicular and base. For perpendicular and base, we know it's 10 alpha. It's 10 alpha, that is perpendicular upon base. Now 10 alpha perpendicular, that is this. Okay, CM, that is CM, and base is FO, so it will be FO, that is a second equation. Then if in triangle BCM, that was ACM, now BCM means BCM, that is making a triangle like this, BCM. Here same 10 beta will be used, perpendicular upon base, because we have to find the hypotenuse, that is beta. Now 10 beta is equal to perpendicular, we are having same, perpendicular is CM and the base is FE, so it will be FE. Now that is the third equation. Okay, now we are putting the values. Okay, putting the values in equation 1. Now equation 1 was m is equal to beta upon alpha. M is equal to beta we are having CM upon FE, that is divided by alpha is CM upon FO. When we convert it, CM upon FE multiply by FO upon CM. CM to CM cancel, M is equal to FO upon FE. That is the magnification formula of astronomical telescope. Okay, and we know the length of if you want to find the length of telescope, the formula for the length of telescope is L is equal to FE plus FO, that I have told already. Okay, so that was all about the telescope, the astronomical telescope.